All right, let's dive right in. Welcome to today's Explainer, where we're going on a bit of a journey to explore a fundamental force that drives literally all human understanding. And that force? It's curiosity. As human beings, we're just naturally wired to ask questions, right? I mean, from the time we're kids, we're constantly poking at our surroundings, trying to figure out how the whole shebang works. Today, we're taking that incredible, innate curiosity and using it to uncover some real secrets of the universe, bridging the gap between these massive cosmic mysteries and the tiny, invisible sparks we feel right here on Earth. Welcome to the wonderful world of science.
Think about your own daily life for a second. Have you ever just looked up at the vast night sky and wondered exactly why the stars shine? Or maybe you've watched a flower bloom and thought, how does it actually know when to open? Now, on a much more physical level, have you ever slid across a car seat, grabbed the door handle, or maybe held the iron bar of a bus and felt that sudden, sharp electric shock? You know the one. These might seem like completely unrelated events. One is cosmic and distant, the other is immediate and, well, slightly painful, but they are both profound mysteries just waiting to be solved. When you look at the sheer, breathtaking scale of the universe, you realize that science is essentially a giant, unending jigsaw puzzle. Every single new discovery we make, whether it's mapping a swirling galaxy millions of light years away or just understanding a tiny grain of sand, adds another crucial piece to that puzzle. And honestly, the absolute best thing about this puzzle? There's no limit to what we can discover. Every new piece of knowledge naturally leads to more questions, more things to figure out. Sometimes we even realize a puzzle piece was put in the wrong place entirely, and new discoveries completely change our foundational understanding of the world.
Moving into Section 1, the puzzle of science, exploring our world.
You know, groundbreaking scientific discoveries often emerge from the most unexpected extremes. It doesn't matter if we're looking at a blistering, dry desert landscape or diving into the vibrant depths of an ocean reef. The crucial point here is that science isn't just some rigid subject confined to heavy textbooks or high-tech laboratories. It's a dynamic way of thinking. It's a way of observing and doing things that applies everywhere around us. From what's cooking in your kitchen to what's happening on the local playground, there is always something new and exciting to discover. It really all boils down to keenly observing your surroundings.
Section 2, the scientific method. Science in everyday life. So, how do we actually go about solving these mysteries in a structured way? Well, we don't have to look up at the cosmos to find mysteries. They are literally in our daily routines. Why did your pen suddenly stop writing? Why did a pot of dal boil over? Where did the air leak out of that flat tire? Or is that broken light fixture an issue with the bulb or the switch? By tackling these incredibly relatable, low-stakes problems, you're already acting like a scientist. Without even realizing it, when you try to figure out the answers to these everyday hiccups, you are applying logic and observation. Let's break down exactly how you do that. Here are the 5 formal steps of the scientific method that you already use all the time. First up, you observe something interesting or problematic, like, okay, your pen stops writing. Second, this makes you wonder, so you ask a question. Why did my pen stop? Third, you guess a possible answer. Maybe you guess the ink is finished. Fourth, you test that guess by opening the pen and checking the refill. If it's empty, hey, your guess was correct. But if it's full, you move to step 5, analyze the results, and realize you need a new guess. Maybe the ink just dried up. You test that new guess. This step-by-step process of guessing, testing, and analyzing is the core engine of all scientific discovery.
Which brings us to Section 3, the spark of static electricity.
Now, let's take this powerful scientific method and apply it to a new, invisible mystery. Remember those everyday experiences we mentioned earlier? Getting that sudden shock from a bus iron bar, or hearing the loud crackle of your synthetic clothes when you take them off in dry weather? To solve this puzzle, scientists had to observe and ask questions, tracing the phenomenon way, way back in time. Around 600 BC, Thales of Miletus noticed that rubbing amber with wool gave it this invisible power to attract light objects. Fascinatingly enough, the ancient Greek word for amber is electron, which, you guessed it, is exactly where our modern word electricity comes from.
This ancient observation perfectly leads us to a formal definition for our modern understanding: electrostatics. Now, static just means anything that does not move or change with time. So electrostatics deals specifically with the study of forces, fields, and potentials arising from static charges. When you rub insulating surfaces together, like amber and wool, or say your synthetic sweater against your skin, electric charges accumulate. That sudden zappy sensation you feel when touching a car door is simply the rapid discharge of those accumulated static charges right through your body.
Moving on to Section 4, the polarity of charge.
The crucial takeaway so far is that rubbing objects together creates an electric charge. But are all these invisible charges exactly the same? Well, through years of careful effort and rigorous experiments, scientists observed something pretty strange. If they rubbed two glass rods with wool or silk and brought them close together, the glass rods actively repelled each other. They pushed away. The exact same thing happened with two plastic rods rubbed with cat's fur. But if they brought the electrified glass rod near the electrified plastic rod, they attracted. These simple observations reveal the fundamental rule of our universe. There are two distinct kinds of electrification. The rule is beautifully simple. Like charges repel each other, and unlike charges attract each other.
And this differentiating property is exactly what we call polarity. One truly fascinating observation scientists made during this testing phase is what happens when these objects reunite. When a glass rod is rubbed with silk, the rod acquires one kind of charge, and the silk acquires the second kind. Naturally, they attract. But if you let the electrified glass rod physically contact the silk again, the very thing it was just rubbed with, they suddenly no longer attract each other. They stop attracting other light objects entirely. It's basically as if the opposing polarities completely neutralize or cancel each other out upon contact.
Section 5. Measuring invisible forces.
So, okay, we know these charges exist and we know they have polarity, but since we literally can't see these charges with the naked eye, how on earth do we confidently analyze them? To measure this invisible phenomenon, scientists invented an incredibly clever tool called the gold leaf electroscope. Just imagine a vertical metal rod housed safely inside a box. Attached to the bottom end of this rod are two extremely thin leaves made of gold. When a charged object, like our rubbed glass rod, touches the metal knob at the top, the charge flows straight down the rod to the leaves. Because both leaves receive the exact same kind of charge, and remember, like charges repel, the two gold leaves push away from each other and diverge. The wider they spread apart, the greater the amount of charge. It's a remarkably simple, yet totally genius way to visually indicate the amount of invisible charge.
Whether we're trying to figure out why a pen won't write, why that doll overflowed, or designing a gold leaf electroscope to measure invisible static forces, it all comes back to this one central idea from our source material. After all, to be a wise person, you must be a wise person. I absolutely love that. Science is fundamentally about joyful exploration. It's about keenly observing your surroundings and never, ever being afraid to ask why and how.
What you should really take away from this explainer today is that you are already equipped to be a scientist. You use the scientific method every single day to observe, guess, test, and analyze the world around you. The universe is just a massive jigsaw puzzle full of things we don't yet know, waiting to be explored. Which leaves me with one final question for you to ponder today. What other invisible forces are shaping the world around you right now? Keep observing, keep that curiosity alive, and keep asking questions.